Hey guys, welcome to this LOFI code test session. Primary reason for today is to make sure that setup is working and the audio sounds good, and also that I'm not getting any DMCA violations. This last time I had some music playing that was supposed to be DMCA free, but was apparently not. So making sure that we're all good there, and do a little test session here. Make sure my setup is working properly, and then hopefully here soon I can get these going regularly. So yeah, bear with me here while I do some testing and listening to live stream. Just a second here. I'm gonna try and switch a couple. Okay, let's try it now. I don't know if that's better. Testing 1, 2, 3. That might be a little better. Testing, testing, testing. 1, 2, 3. This is a full audio test. See if the rumble goes away. Still there. Let's try it now. See if this is any better. Turn the gain down a little bit on my microphone. Doesn't seem to be any better. See what's causing the problem. Testing, testing, 1, 2, 3. Testing. Testing, testing, testing. 1 and 2 and 3. Seems like it's better. I'll try this. Turning my gain up a little bit here. Testing, testing, testing. 1 and 2 and 3. Testing. 1, 2, 3. Testing. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Testing. 1 and 2 and 3. Testing, testing. Not any better. Try this. Testing, testing. 1, 2, 3. Testing. And 1 and 2 and 3. Let's try this. Testing, testing. 1, 2, 3. Testing, testing. 1, 2, 3. Okay, I think that sounds better. A little less of that rumble there. Try this. Testing, testing. 1, 2, 3. Testing, testing. 1, 2, 3. Testing, testing. 1, 2, 3. 1, 2, 3. Is the rumble gone? Sounds a bit better. Try this. Testing, testing. 1, 2, 3. 1, 2. Testing, testing. 1, 2, 3. 1, 2, 1, 2, 1, 2, 3. One, 2, 3. 1, 2, 3. 1, 2, and 3. Testing 1, 2, 3. Testing 1, 2, 3. 1, 2, 3. 1, 2, 3, rumble, rumble. Is the rumble gone? Is the rumble gone? Is the rumble gone? Is it gone? Is it gone? Is the rumble gone? Is the rumble gone? Is it gone? Testing 1, 2, 3. Testing 1, 2, 3. Sounds good enough now. In case you guys can't tell, I'm really picky about my audio. And it's just killing me that this rumble exists. Probably because of all of the fans and whatnot that I have going on, and I'm using a lot of noise suppression to get rid of that. I imagine that it probably has something to do with that. I can still hear it. Is the rumble, 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 rumble. Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3. Do this, but let me see what happens if I flatten my equalizer and get rid of it. Let's see. Testing, is the rumble gone? Is the rumble gone? Is it gone? Testing 1, 2, 3. Yeah, it's not as bad for sure. Alright, well, we will keep it without the equalizer for now until I can figure out why that's happening. So it still sounds like it exists. It might just be the equalizer that's pulling it out of the signal. Okay, anyway. So one of the main reasons that I'm doing this is that my co-host, Jacob, is wanting to learn Python and coding, and I thought back to when I was learning coding, and one of the things that would have been really beneficial for me and kind of helped things make a lot more sense was being able to see somebody do it and explain what they were doing while they're doing it, and kind of seeing that almost practicality and implementation element of it, I think would have been really helpful. So I offered to do that for him, but the problem is he lives about 45 minutes away from me. And so it means typically we only really get together whenever we're doing a podcast, for now. And so I figured maybe to get that started, I could start doing these live coding sessions so that you could follow along and maybe watch them later if he's not able to see them live. So right now what I'm working on is this library that I created called LSTM Tools. And I really created it as a personal tool for myself because I got tired of working with the existing tools, mainly Pandas and Pandas library and NumPy, when I was trying to work with complex sequential data that involved windowing and changing dimensions several times, because things just get really hairy whenever you're switching dimensions and creating sliding windows. And so Pandas isn't really optimized for that. They're more of dealing with two-dimensional arrays, and that's kind of where their specialty, I guess, lies. And then NumPy is not optimal for that because you deal with everything on an index basis, so you have to trust that you are always accurately specifying the index, and it's just really easy to make mistakes that way. So this library was meant as was kind of personal tool that I put together to solve that problem, allowing me to access features across dimensions really easily through typical dot notation with Python. Makes it feel a lot more Pythonic. Kind of dynamically shifts the classes and functions that are available, or the class and functions that are available, depending on the shape of the data and the current kind of view of the data you're looking at. So like it takes a different shape when you're dealing with windowed samples versus regular samples versus looking at a specific feature. And I did already release this library on both PyPy and GitHub, but what I'm doing right now is I realized once I released it that there was one of the classes didn't have the same some of the same intuitive elements as the other class, namely with the Chronicle class, which deals with data on a three-dimensional level. You weren't able to access features via dot notation, so I was attempting to fix that, and then realized I could implement a couple more things to help kind of ensure things remained intuitive and the way you naturally want to handle them. So this is actually a good example of the library in action here. This is just a test file that I'm running for kind of keeping track of what I'm doing, make sure things are working properly. But what we've got going on here, let's restart this. So we're loading a sample is the same shape as typically what you'd find with a Panda data frame. It's two-dimensional array. So that said, you can load. It's designed in a way that lets you load CSV files. Directly. So just pass the file to the sample class, and then if we were to just take a look at that, you'd see things in their sample form here. So within the sample, we've got a time frame, and within each time frame, we've got our features. So here we are accessing our windowing settings, which is kind of something that I started doing for another library that I made, an audio library, when I was dealing with a lot of different settings. The function arguments were getting nutty, and just like some audio functions, had 10 plus different settings that could be adjusted. And so I started making settings classes, and really liked kind of handling things that way. So translated over here. So here what we're doing is we're setting our window sizes for any windowing that we want to do. And for this, it's our historical window. And the difference between that, the reason that's specified is because we also have future windows, and it's so that you can create kind of this split sliding view for training LSTMs, of a historical view of data and then a future view. So we're setting our window size to be 6 hours here, and then we're just calling keeping the stride the same, so it's just going to shift by 1 over the array, and then we are calling our historical sliding window function to create a historical sliding window, obviously, and supposing I didn't screw anything up. Yep. Okay, good. We've got now a chronicle. So a chronicle deals with things on 3 dimensions rather than 2. Each chronicle, we've got samples. With each sample, we've got time frames. In each time frame, we've got features. So what was I doing earlier? Something a second ago. Yes. So as you can see here, even with the 3-dimensional data, one of the cool things that we can do is actually we don't even need to do that now, I don't think, because I think if I just access the C6 hour dot low, should return a feature or a feature sample. I forgot to add the cutoff implementation there for that. We've got a feature chronicle now, which basically means that since we created a chronicle windows of our sample data, we can now get specific features from each of those windows, or from each of those, those windows here. So we go all the way down a lot because we're dealing with a lot of 300 something, 360 entries, but see all this right here. These are the features from a window. And what that allows us to do is then easily compress and get the statistics for each window within this feature chronicle. So ideally, the way that I'm working on setting this up right now is that we would then be able to do something as simple as load dot mean, and that would give us the mean of this of each. Would give us a new array of calculated mean values of these features within the window, or these feature samples within the window. So but in order to be able to do that, we need to implement the handler, which basically is going to press each window individually, accessing the underlying array, with a raw numpy array, and then needs to figure it back into not a sample, because samples are more than one feature. Probably feature sample. Yes, feature sample. So now what we can do is exactly what it's suggesting here, and we can implement our operation handler across the board for these calculations. Let's test that. worked. It wasn't quite as fast as I was hoping, but considering how many different compressions we're doing here, it's actually not that bad. Look at all this. That was and on top of that, part of that time is printing it out here, because there's even more that it didn't show. In fact, let's take a look at the shape here. Yeah, 250,727 compressions in 4 seconds. It's not that bad. And one of the other cool things that we can do is we can actually add multiple compression, even custom compressors to our kind of compressors list within the class. And whenever we run compress, it will basically take care of running all of those on the feature and compressing them down, naming them, and then compiling them back into a sample for us. So that makes kind of dealing with, say you wanted to calculate this, the standard deviation, kurtosis, skew, mean of a feature sample, rather than having to do those individually, you just go ahead and add those functions to the compressor or your list of compressors, and then run all the compressions at once and have it pull the names and compile it all into a sample, a new sample for you with the compressed data. So I think I'm going to here, I'm going to put a add compressor function. Gotta love autocomplete. Okay, so yeah, now we can chain compressors together, or adding compressors. So we could say something like, basically what that would allow us to do is go something like that, and then we could just call compress, and then boom, it would return us the sample, all the new compressed features. Now, something else I am working through is I'm trying to find a similarly intuitive and easy way of doing the same thing, but with windows sizes of different lengths. So basically allowing you to be like, okay, I want to create a window that is, 6 hours long, a window that is 2 hours long, 1 hour long, 30 minutes long, and 5 minutes long. And I want to compress using these methods, and then I want to have those compiled into a new sample and want to do that in a sliding window fashion, creating ultimately a chronicle of those. But yeah, that's basically kind of what I'm doing with the LSTM tools. And it just takes a lot of the room for error out of exploring different data formatting techniques and training models. So I'm gonna call it there for now because it's a test stream. So anybody who watches this, thank you for watching, and hopefully we'll get some full length streams coming out here soon. And hopefully we actually get some people in here to join in the conversation. I will see you guys then.